Hello, hi there. Today I'm going to teach you how to draw the displacement versus amplitude graph, right, of a what longitudinal wave. For a transverse wave, it's already given in the waveform, but in a longitudinal wave, this type of wave, how to convert to amplitude versus displacement firstly. Let me just explain you how that one, and the next one is how to change the pressure, right? Pressure versus displacement, right, of the graph. I'll tell you how does those two exactly change. Firstly, let's take a look at how the waveform occur in a wave. Right, this is a certain material. So in this material, you can see this is waves undisturbed. The particles are undisturbed. In these particles, it may just vibrate like in this manner. So the vibration may occur in all the particles. I only randomly mark one or two. So when you hammer something, right? When you hammer this one, this one, it will get particles get disturbed, right? Let me explain you how does it happen now. So once the particles were disturbed, like in here, this particle will trying to travel to the other direction, right? Let me explain you like using multiple of particles. All these particles may just move towards here, then collide with the other one because of the electrostatic repulsion. Uh, the other one also moves to the other side. The other one also keep continuing. So these particles may keep continue to move towards the right hand side, but not keep continuing. It just vibrate to there and come back, vibrate to there and come back. So like this, it will transfer the vibrational energy to particle, nearby particle, due to electrostatic repulsion and attraction among these particles. Right. Now, once this happen, so the particles behave like in a certain weird manner. In some group of the particles act together and compress together. This type of region we used to call this as compressions. Compressions. And here the other one is known as rare fractions. Again, compression, rare fraction. Compression, rare fraction. Right. So now let me explain you something really important here. Right. In the compression, I now enlarge the compression up here. You may see the particles are just wide apart. So these particles from both the sides move, begins to move towards the center of this line. I'll draw like this line. See, that's the center line. So always compress from both the sides. This side also compresses together. Now the middle part. How about the middle right? It cannot move because from both the sides it comes towards it. So the middle region cannot move. That's the first thing you have to understand. Now in the rarefaction thingy, the wave particles move apart from the middle. Particles are moving apart from the middle. Particles are moving apart from the middle. Now it may just make this type of arrangement. Now it's kind of stretch. So the stretch take place in the other particles. The middle line is always remaining undisturbed. It cannot move, right? What is the amplitude? According to the definition, amplitude is the maximum displacement from the central line, right? So the central line is this one, no motion after that. How to keep that in your mind a lot. Now see how does it change. Now in this axis, draw the axis. In the y-axis, I just mark the amplitude. And in the x-axis, displacement, right? How does it change? How we look at the middle line, it is zero displacement. The middle line of this one, again zero displacement. So zero, 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 zero displacement, right? You have to remember one thing, it always makes, but the amplitude in the negative direction because the compression is taking place between here and here. So compression is maximum at here. The particles are moving fast towards here. So it's the most lowest point. Then this one is trying to spread. The particles are getting compressed here, and this one particles are beginning to stretch. So stretch keep continuing, and then see, firstly it brings to the some zero level of the vibration, then again keep increasing. So how to understand one thing? between what? Compression to middle region between the compression to, sorry, reaction has the lowest, and between reaction to compression has the highest peak. It's the all thing you have to understand. Remember again the key points to remember. Middle lines of the compression and the reaction, self zero displacement. And the middle line between the adjacent one, compression to reaction, has the lowest amplitude in the negative axis, and the reaction to compression has the highest. To draw the graph like in this manner, the pressure versus displacement graph is extremely easy to understand. How would that? The pressure, here the y-axis is pressure. That is pressure versus displacement. Right? How would look at here? The pressure is maximum in the middle line of the compression, and pressure is lower in between, and zero because it's just getting relaxed. And the pressure is extremely lower in the middle of the reaction. Again, pressure is maximum at the middle of the compression. Pressure is minimum in the reaction. It's really easy to understand this part. So there might be an MCQ given, at least like 6 marker can also given in this one. How to explain why and how. So I hope you enjoy the video. Like them, subscribe, and share with your friends. Thank you.